Good morning, boys and girls. We're going to look at 3-digit by 2-digit multiplication. And I am going to show you a few different ways today. I'm going to show you how to move the decimal point, which we have already done this. So if we start here, if we multiply by 10, that means we're going to move the decimal point one place to the right, okay? So we're gonna move it to the right one place. If we're multiplying by 100, we're going to move it to the right two places, okay? Then if we are multiplying by 1,000, we are going to move our decimal to the right 3 places. And this is what we worked on, boys and girls, a couple of weeks ago when we were multiplying and dividing by the powers of 10. And that's another reason that we showed you that multiplication strategy, because we are going to be working on it. Okay? Right now, we're going to start over here on the right side. We're going to call this the standard algorithm way. Also, your parents this is the way that they were taught, the old school way. I'm going to show you a way I do it, and I call mine the Daisy Dinosaur way, but it's pretty much the standard algorithm way. What I do is I draw a dinosaur head so that I know that I have to stay within the ones place. So I'm going to start at the ones place, and I'm going to ask myself 9 times 2. 9 times 2 is 18, so I'm going to put my 8 down, and I'm going to carry my 1. Notice I kept it inside my dinosaur head. Then I have 9 times 3, which is 27. Then I have to add the 1, which gives me 28. So I'm going to put my 8 down, carry my 2. Then I do 9 times 6, which is 54. Then I'm going to add 2 to 54, which gives me 56. That's my beginning row. Then I'm going to mark out those that I just used. Now, we are moving over to the tens place. So now my Daisy Dinosaur is going to drop an imaginary 0 because we don't have a number in the ones place because we're starting in the tens place. So then I multiply my number in the tens place, 4 times 2 is 8. Okay, I don't have anything to carry. Then I'm going to say 4 times 3 gives me 12. And I'm going to carry the 1. 4 times 6 is 24, plus 1 is 25. Then I have to add my ones row and my tens row together to get my answer. Okay. So then 8 plus 0 is 8. 8 plus 8 is 16. Carry my 1. 2 and 6 is 8, and 1 more is 9. 5 and 5 is 10. Carry the 1. 1 plus 2 is 3. So my answer to that problem is 30,963. All right, so how we check this problem, we can check this problem by division, or we can check it with what they call a digital root, okay? Now, we are not going to check with the digital root because that is very confusing, boys and girls, and so I am not going to show you how to check with the digital root. We will work on that later, okay? Now, what we're going to look at is we are going to look at expanded notation and multiplying with expanded notation. So I'm going to show you first when we do expanded notation. Notice I've taken 600, I've broken it apart. 600 plus 30 plus 2, and then 40 plus 9. Okay? Now, how we do it this way, I have First, I'm going to take my 9 times 2. What is 9 times 2? 18. Okay, I'm going to put my 18. Next, I'm going to take 9 times 30. Well, I know 9 times 3 is 27, and I'm going to add a 0. So that's 270. Okay? Then I'm going to take 9 times 600. Okay? 9 times 6 is 54, and then I have 2 zeros, so that's 5,400. So I've done this top row. I've taken 9 times 2, 9 times 30, 9 times 600. Now what I'm going to do is I'm going to take 40 times 2. 40 times 2 gives me 80. Notice I'm lining these up because I'm going to add them when I'm finished. Then I have 40 times 30. 40 times 30, 4 times 3 is 12, and I have 2 zeros, so that's 1,200. So I've taken 40 times 2, now I'm taking 40 times 30, now I have to take 40 times 600. Okay, so 40 times 600, 4 times 6 is 24, okay? Then I'm going to add the 3 zeros, all right? Then I'm going to add these up. 8 plus all those zeros is 8. 8 and 7 is 15, plus 1 is 16. Then I have 2 and 4, which is 6, 7, 8, 9. Okay. 4 and 1 is 5, and 5 more is 10. Carry the 1. Now I get 30,968. So you see here's a couple of different ways. This way is called expanded notation. This way is called standard algorithm. Okay. And then with the partial products, they're going to use the patterns of zeros like we saw here. And you're going to find the products with a multiple of 10.